right, folks. Well, what I'm going to do here is I'm going to review linear functions, just the idea of lines, graphs of lines, line equations, that kind of thing. This probably stretches all the way back to maybe 7th grade math, some of you maybe 8th or 9th grade or whatever, but this is an interesting subject, an important subject. And what I have found is, one, in my opinion, it's very easy to understand. Two, a lot of people do not understand it, probably because they haven't done it in a long time, and so they've forgotten how to do it. But three, it is essential for understanding math in general, especially getting up into higher levels of math. But because there are so many things in math that rest upon the basic understanding of how to identify the equation of a line and how to graph a line, especially in calculus, also in pre-calculus. And so what I'm going to do here is I'm going to review 4 basic subjects within linear functions. We're going to review how to identify the slope of a line that runs between 2 points, how to identify the equation of a line in 2 forms. We're going to go over slope-intercept form and point-slope form. There is another form. There's probably a couple other forms. There's standard form, but I'm not going to do that in this particular video. But if you can understand slope-intercept form and point-slope form, then you're in really good shape. What I found is that most people, they understand the form of slope-intercept form, but they have a hard time drawing the equation or writing the equation of a line in slope-intercept form. But then they don't understand point-slope form, which doesn't make any sense to me because point-slope form is easier than slope-intercept form. So anyway, we're going to talk about that. And then we're also going to talk about how to identify parallel and perpendicular lines. And then we're going to talk about how to graph a line. And I'm going to do this in 4 videos. So in this video, the only thing that I'm going to do in this video is we're going to talk about how to identify the slope of a line. Okay. Now, some people, I think honestly, they don't understand what slope means. Okay. Slope, even though it doesn't have to be physical, it doesn't have to be graphical, it doesn't have to be visual, but in my opinion, the word itself probably comes from something visual. The idea of a slope is kind of like, if you're walking down the road and the road begins to go upward. It's sloping upwards, right? Or it starts to go downhill. It's sloping downhill. Okay, that's what the idea of slope is. But if you're not sure, basically the idea here is the slope of a line is basically the tilt of the line. So if we have a line, let's say that we have a flat, straight line, okay? So here's a line whose slope, well, it's basically flat, whose slope is 0. Some people may say that it has no slope. Actually, it does have slope, but it's a flat slope. It is a slope of 0. And we're always reading from left to right on a graph. So let's say we change this line. What if this line now does this? So going from left to right, this line is going up from left to right. So that means it is sloping upward, or it has a positive slope because it's going up from left to right. On the other hand, if the line does this, if it goes down from left to right, okay, it's sloping down, or we call it this a negative slope. Okay, so that's what we're talking about here. When we talk about the slope of a line, we're talking about how is it tilted up or is it tilted down? Is it going uphill or is it going downhill? And how steeply is it going uphill and how steeply is it going downhill? We have this line that looks like it's going uphill, but if we draw this line is also going uphill, and if we compare it to the other line Let's get rid of these. If we compare it to the other line going uphill, this one is steeper than this one. And something you can think about is, would you rather be walking on this hill or would you rather be walking on this hill? Most people would rather walk on the flatter hill, and so this is steeper than this one. This one is flatter, and this one's steeper. And so this has a larger slope than this one does. Okay, so the slope of this, the positive slope here, would be a larger number than the slope here. Okay, so that's upward slope, that's positive slope. On the other hand, if we have a negative sloping line, if we have one that is steeper, okay, this is still a negative slope, but it's steeper. Okay, it's like if you were here, you would be walking downhill. If you were here, you would be falling downhill. Okay, because it's a steeper slant. Okay, and so that's another way to think about it. Instead of tilt or slope, think of it as slant. How slanted is it? Okay, so this is slanted down to the right a lot more, and so the magnitude of this slope, it's going to be a negative slope, but the magnitude of it is larger. So this could be like a negative 1/2 slope, and this could be a negative 1 slope. Or maybe if this was a negative 3 slope, this could be a negative 6 slope or a negative 7 slope. Okay? So we have the positive and the negative slope, and now what we need to understand is, how do we calculate the slope of a line if it's passing through 2 points on the coordinate plane? So let's say we have the coordinate plane, and let's say that we have a point, let's say we have the point 5, 2, and then we have another point, let's say that this point is, I don't know, let's say 11, 5. Okay, so we've got 2 points, and here's the thing: when we're talking about the slope between 2 points, we're talking about drawing a straight line between 2 points. So if I take a ruler and I connect it between these 2 points, and then draw a straight line between these 2 points, okay, that straight line right there, what we want to know is, what is the slope of that line? Now, just looking at it, I can tell it's a positive slope. And the formula, we use a particular letter to represent slope, and that letter is M. M is, I don't know who chose M. I'm sure it was somebody famous, and I'm sure I don't know who it is because I don't know a lot of those fancy details about math. But I know that M is the letter typically used to represent slope when talking about linear functions. So we have slope, and it's the formula. It goes by a lot of different things. Okay, rise over. People say rise over run. We say delta y, change in y over change in x. But really, you just want the formula. Well, the formula is really simple. The formula is y value, one of the y values, which we usually call y2 first, minus another one of the y values, which we'll call y1, over the x value that goes with this y value minus the x value that goes with this y value. And so what we have here is, this is one of the coordinates, and this is the other coordinate. This is one of the points, so let's say that this is point B. So let's say this is point B right here, and this is point A over here. Okay, so this is the xy coordinate for point B, and this is the xy coordinate for point A. And so now, basically, we just need to plug these numbers in. Well, point B, so our slope here, M, our slope, point B, the y value is 5. The x value is 11. So we'll put 5 here, 11 here, and we'll put a minus, minus, minus. And then over here, we're going to put the y value from point A. Point A, the y value is 2, and the x value is 5. And so what we now have is, we have 5 minus 2, which is 3, over 11 minus 5, which is 6, and 3 over 6 reduces to 1/2. So the slope of this line, M, is 1/2. Okay? So that's how you calculate slope. So let's do a few more examples here, and we're going to do it without the graph. We're just going to put the formula up here. Say that slope is equal to y2 minus y1 over x2 minus x1. So if we want to know the slope of the line that passes between the point 73 and 41 and the point negative 16 and 62. Okay, so we have these 2 points, and we want to know the slope of the line that passes between them. So we'll say m is equal to, and it doesn't matter which point you choose first. Some people are going to argue, probably in middle school, a middle school teacher is probably going to argue that your y1 and your x1, that's just not an insult. I'm not trying to insult middle school teachers. You're trying to make things simple. You want to give the students direction, right? Okay. Well, what I'm trying to tell you, though, is, so they're going to say that y1 and x1, that the x1 is the smaller x value. So negative 16 is smaller than 73. So that means this negative 16 is going to be x1, and this 62 is going to be y1. Well, what I'm telling you is it doesn't matter. You're going to get the same answer no matter what. You just have to put this vertically on top of each other. This has to be one of the coordinates, and this has to be the other coordinate. And I'll prove it to you. So we'll do y2 and x2 right here. We'll do those first. y2 is 41 minus over 73. Put a 73 here minus, right? So we got x1, y1, okay? Or excuse me, x2, y2, sorry. And then here we have, we'll put x1 down here, negative 16. Put it in parentheses because it's a negative number. And then y1 we'll put right here, 62. Okay, watch what's going to happen. So 41 minus 62, right, is negative 21. Negative 21 over, and then 73 minus negative 16, well, minus negative, that means plus, right? We're adding. So 73 plus 16 is 89, right? And so let's see here. 3 won't go into that. 7 won't go into that. So I guess we're good. Okay, so our slope here is going to be negative 21 over 89. Okay, well, let's say that we swapped them around. What if I did m is equal, what if I put the 62 first, minus, and then the 41, over the negative 16 first, minus the 73. Let's see what we get. Well, 62 minus 41, that's 21. Negative 16 minus 73 is negative 89, and a positive divided by a negative is a negative, so this is the same thing as that, right? We got negative 21 over 89. It's the same thing. So it doesn't matter which of the 2 points you put first and which one you put second. You're going to get the same slope no matter what. What you have to make sure that you do is you have to make sure that you put these 2 numbers on top of each other and these 2 numbers on top of each other. You can't do some sort of crazy diagonal thing. Okay? All right, so let's do another one now. So now that you know that it doesn't matter which order you put them in, let's calculate another slope. Our formula is m equals y2 minus y1 over x2 minus x1, right? And let's say we want to know the slope of the line that passes there, that goes between 2 points. Let's say one of the points is 1 and 15. Let's say that the other point is 7 and negative 3. Okay? Why don't you pause the video and see if you can calculate this on your own. All right, so let's see here. Our slope, we got our formula. We got to do a y minus a y over an x minus an x. Well, here's a y, 15, minus a y, negative 3, over the x that goes with the 15, well, that's 1, minus the x that goes with the negative 3, well, that's 7. So 15 now minus negative, that means positive, plus, right? So 15 plus 3, that's 18. And 1 minus 7, that's negative 6. And 18 divided by negative 6 is negative 3. So the slope of the line that passes, or that connects these 2 points, the slope of that line is negative 3. Let's do a couple more, and I think you'll be in pretty good shape. All right. What is the slope of the line that connects the points negative 5 and negative 9 to the point negative 13 and positive 1, let's say. So here's a point on the coordinate plane. Here's a point in the coordinate plane. All right, you can think about where they are. See if you can figure out the slope of the line that connects these 2 points. Go. All right, so let's see here. We're going to do slope is equal to one of the y values, let's do negative 9, minus the other y value, which is 1, over the x value that goes with negative 9, which is negative 5, minus the x value that goes with 1, which is negative 13. So I'll put parenthesis negative 13. All right, so negative 9 minus 1 is negative 10. And then negative 5 minus negative. So we got negative minus negative is plus. So I got negative 5 plus 13. That's going to be positive 8. So I got negative 10 over 8. 10 and 8 each can be divided by 2. So we're going to divide this by 2, get negative 5. We're going to divide this by 2 and get a 4. And so our slope between this point and this point, the slope of that line is negative 5 over 4. Okay? So that's basically how you calculate the slope of the line. In my opinion, it's not really that complicated. You just do a couple subtraction problems and then you leave them as a fraction. You can turn the fraction into a decimal, but here's what you got to understand. If we're going to graph this later, we, math people, usually do not turn it into a decimal. We usually leave it as a fraction because it makes it easier to graph later. Okay? So there you go. That's the slope of a line. I'll see you in the next video when we talk about how to write the equation of a line in slope-intercept form and point-slope form.